In this session, we will talk about a microprocessor. These are the operations with least human interference. To understand it, let us see the working of a computer. This is the block diagram of a computer. It has a central processing unit, input device, output device, and the memory. CPU is the heart of a computer. Basically, CPU has two units, arithmetic logic unit and control unit inside it. ALU does all the arithmetic and logic operations. Arithmetic operations such as addition, subtraction, multiplication and division. Addition in this case is addition of any two numbers. Subtraction is subtraction of any two numbers. And similar is the case for multiplication and division. ALU also does logic operations such as ANDing, ORing, XORing, and complementing. Let us come to the second part of the CPU, that is, control unit. Control unit is linked with input device, output device, memory, and ALU, and controls all the internal operations. Let us see how a computer works. Through input device, instructions are given to the CPU. CPU interacts bidirectionally with the memory where program and data are stored. Finally, the output is sent to the output device. In this computer, keyboard is the input device and output device is the monitor where results are displayed. According to the capabilities, computer systems have been divided into three categories: mainframe computers, mini computers, and microcomputers. Let us have a look at all of them. This is the mainframe computer. System unit houses the CPU and onboard memory part of the computer. All these extra units are known as peripherals and are connected to the system unit. Since mainframe are the most powerful of the three categories, they are the most complex too. Because of their high level of complexity, their arithmetic logic unit and control units are separate ones. But when these two units are put on a single chip, that is known as the microprocessor. Second categories of the computer system is mini computer, less capable than a mainframe but more capable than a microcomputer. These are the microcomputers, third category of the computer system. In a microcomputer, ALU and control unit are on a single chip known as microprocessor, which constitutes the whole of central processing unit of a microcomputer. Let us now see the principle behind the microprocessor. To understand it, let us study a simulated microprocessor. Let us say we have two numbers 15 and 5. These numbers are stored in temporary storage elements known as registers in microprocessor language. Using digital gates, we have made an adder, subtractor, multiplier, and divider, which will act as ALU. This microprocessor has two inputs, P and Q. Each one can be assigned the value with either 0 or 1. By assigning different values to P and Q, we can have 4 different combinations. Each combination will correspond to different functions. Let us say if the combination is 0, 0, that is PQ is 0, 0, ALU adds. If PQ is 0, 1, it subtracts. If PQ is 1, 0, it multiplies. And if PQ is 1, 1, it divides. These 0, 0, 0, 1, 1, 0, 1, 1 are known as operation codes. Do you know what decodes the operation code and selects the function? This is done by control unit. Let us see what happens if we give 0, 0 at the inputs. Control unit enables the adder part of the ALU and the output is 15 plus 5 equal to 20 appears on the output device. Now, if we make the inputs 0, 1, subtractor is selected. And the output, that is 15 minus 5 equal to 10, appears on the output device. Let us make the input 1, 0. It will multiply and the output is 75. If we make the input 1, 1, the output is 3. In the above case, since we are giving our instructions through only 2 lines, P and Q, which are known as data lines, we can have at the most 4 unique combinations or 4 instructions. First instruction, 0, 0. Second instruction, 0, 1. Third instruction, 1, 0. And fourth instruction, 1, 1. Microprocessor is the extension of this principle. If we have 3 lines, we can have 8 different combinations or instructions. But to make this simulated microprocessor a sufficiently powerful system, it has to have more numbers of data lines or wider data bus so as to accommodate more number of instructions. If the number of lines are 2, the maximum number of instructions can be 4. And if the number of lines are 3, the maximum number of instructions can be 8. Similarly, if the number of lines are 8, we can have 256 different instructions. A set of lines is known as a bus. If the bus is meant for flow of instructions or data, it is known as data bus. And if the purpose is to send address of the memory on the lines, it is known as address bus. Let us see what is there in an actual microprocessor chip. Microprocessor Intel 8085 is one of the most popular 8-bit microprocessors. The word 8-bit refers to the width of data bus, that is, data lines are 8. 8085 has a data bus 8-bit wide, which means it can have 2 raised to the power 8 equal to 256 different instructions. Can you imagine what is inside this tiny 8085? It contains many units. Whether it is industry or home, the microprocessor, by doing automatic and sophisticated operations, creates wonders in this modern world.